Welcome back to our video series on Wi-Fi 7 clients. As was evident in the link you clicked, we are going to be reviewing the Apple iPhone 16 Plus. So this is, like the other cards, is a 2x2, supports 4096 QAM. Unlike the other cards, this one only does 160 megahertz of bandwidth, which we'll see in the CLI on the Aruba AP. And we have yet one more type of MLO operation mode. So this is non-simultaneous transmit and receive, multi-link, multi-radio. The Qualcomm was similar, but it was simultaneous transmit and receive. So the non-simultaneous transmit and receive, from what I understand, is for devices that the radios are too close together to try to discern the energy from both transmit and receive at the exact same time. So they put it into the MLO operational mode for non-STR. There is no Wi-Fi certification, so Apple stopped certifying their products with a Wi-Fi Alliance, I think, sometime around the iPhone 15. Doesn't mean that, obviously, the product doesn't work. We're about to determine some of that here in a minute, but there is no Wi-Fi certification for that, so no link in the notes. You can go ahead and feel free to search for it, but you will not find it. This particular iPhone is running 18.1.1, which is the latest iOS as of this video. And we do see this one, unlike the others, it does support WPA3 Enterprise with MLO operation. The other cards would associate with with WPA3 Enterprise, but not with MLO. And in addition, the pre-shared key on this one does not support MLO. So it's the exact opposite of the other cards. So I did a bunch of testing with pre-shared key, and I could not do a multi-link device setup on any of them. It would just associate to the one band. All right, let's go ahead and get into the details. So lots of really cool things to explore here with the iPhone. So first we'll take a look at how I have the SSID setup, or the BSS setup. So we're going again across all three bands, and I do have pre-shared key and enterprise WPA3 enabled. So for this particular set of tests, I'm once again using 320 megahertz wide channels on 6 gigahertz, just because that's where it was before, and then 160 wide on the 5 gigahertz and 20 megahertz wide on 2.4. So take a look at the client association. We see some really cool stuff here. Let's explore it. So first off, notice that I connected with Enterprise. So 8021X Enterprise WPA3 Enterprise Authentication did negotiate MLO, unlike all of the clients I've tested thus far in the Windows 11 desktop. And on top of that, it did multi-link device setup across all three bands. So it's the first time we've seen this as well. So it's on 6 gigahertz, 5 gigahertz, and 2.4 gigahertz simultaneously. We do see a new mode of operation. So we see that it's doing a multi-link device for non-simultaneous transmit and receive, multi-link, multi-radio. So that's a first for both of those. So non-simultaneous transmit and receive, MR. So just a recap on that from the Intel guide, we're operating in this mode here. So the NSTR signifying that we cannot simultaneously transmit and receive. We can only go one direction at the same time. Whereas if it did negotiate simultaneous transmit and receive, we could transmit and receive simultaneously, but that's not what the iPhone is linking up at. So getting back to the AP's perspective here, so if we take a look at the MLO setup here for this particular client, and again, I know there's a lot on the screen here. It's really hard to to focus in on one thing here. Tell you what, actually the MLO association is a little bit easier to read. So we could see here that we did multi-link device setup, same thing we saw just a minute ago, and across all three bands, so 6 gigahertz, 5 gigahertz, and 2.4 gigahertz, as is displayed down below. So another interesting thing that we see here is that the PHY capabilities, or the capabilities of the chipset within the iPhone, only supports 160 megahertz wide channels, 2 spatial streams, but it's only doing 160, as the Windows cards were doing the full 320. So not only is it only capable of 160, it did associate at 160 as well with the 2 spatial streams across all three bands. So pretty cool there. So there's no way really to look at the specifications from the device itself, as Apple hides all that stuff. So really, all we can glean from it is what we're doing for this analysis and whatever we can find on the internet. All right, spectrum analysis. So I'm going to combine both tests into the spectrum analysis because I've obviously already have run these tests and I know what's going to happen. So I do want to show everybody here though. So as always, I've got 5 gigahertz on the left hand side and 6 gigahertz on the right hand side. We do know that it is connected tri-band. I don't have my other spectrum analyzer up and running, but I can tell you we can flip over to it here, and we do see 2.4 activity. I don't have a clean band, so I can't isolate showing that the iPhone may be driving a little bit of traffic on here, but what we are going to do is when I do my speed test, which is I'm going to start now to drive energy, we do see nothing's happening on 2.4 here. We don't see any increased utilization anyway. Is it potentially talking to the AP for other applications potentially? That's obviously using 6 gigahertz over on the right hand side. If we take a look at 5 gigahertz, it's clean. So I don't have any other. I've got the Uni 2 shut off in the rest of my environment. So the only thing we'll see here is the Wi-Fi 7 AP, and we do see channel 100 tick up every now and then. So there we go. So there's the iPhone talking. Not too sure if it's transmit or receive on 5 gigahertz. So on the right hand side, we see that I have my co-channel interfere there centered on channel 21 negative. So it's using 40 megahertz wide of bandwidth. And if I run a speed test now over on my interfere, nothing happens other than the both clients suffer. So I took a drastic throughput hit on the iPhone, and I'm not getting very good throughput on the interferer either. So I did play around with this a bunch. So I tried all sorts of different size channels for both the 6 gigahertz for Wi-Fi 7 as well as the co-channel interferer. And what was interesting is that when I had the channel sizes set the same, so when I had them both set 160 megahertz wide, the performance was good. I was showing, approximately 1.5 gigabits of throughput on one client, and as I introduced the co-channel, it would steal about 400 megahertz, 400 megabits of throughput, and then the iPhone would dip down to about 1.1 gig or 1 gig. So it was equally sharing that channel, and they were sharing it responsibly. But when I did things like this, when I was trying to get the client to shift its traffic over to one of the other links, it just won't do it. It doesn't appear to be doing any spectrum puncturing because, as you see, it's just sitting there struggling over on 6 gigahertz. No matter what I did, even if I shifted that interferer over to the lower half of the band, or 20 megahertz wide on either side of that band, it just made no difference. So I'd have to say that spectrum puncturing is not functioning on the iPhone. And it's not doing a very good job of shifting over throughput during times of congestion there. So I'd say that's a fail. So more things, I guess, to come later on when we get new updates to the iPhone, and this could be Aruba AP where we're not puncturing out that particular channel for this type of MLO type. It could be from that perspective as well. So as I see improvements or enhancements to this, I'll update the videos and do a post. Packet analysis. So I skipped over the beacon frames because we've already gone over the Aruba beacon frames in multiple videos. If you want to see the details on that, look at the show notes below for the AP755. We go into all the details, and nothing's changed on the AP other than maybe some channel width. So they will all be identical. So what we're looking at here is the iPhone's probe request. So if we find the request coming for the enterprise WPA3 network and for the proper transmitting address for that, here we are here, 61 dB that we saw in the CLI review, and this is 6 gigahertz. So if we take a close look here, collapse all that. And nothing in that one. There we are. So multi-link, probe request, and we see it requesting no station information for any of the other bands, which I thought was interesting. If you take a look even at 2.4 gigahertz, if we scroll down here, see if I can find it without collapsing everything. Multi-link, also 0. And if we take a look at 5 gigahertz, I'm going to collapse that. That was very confusing to try to find that. Collapse all. So same thing here. So over on 5 gigahertz, it's also not asking for station information for the other link. So we do have the probe requests individually on all 3 bands, but not asking for the other links. And I did run these captures multiple times, and it was the same result every time. So that is a different behavior than the other clients we've analyzed. So if we take a look at the probe response, get everything collapsed. So we'll hunt down a probe response here for the enterprise network. We are here, so CE 11 to 61 dB. That is a probe response here. And we have our multi-link. The probe response, however, does respond back with all 3 links. So itself, right now we're on 2.4 gigahertz. So we get the response for that plus the other 2 bands, specifically here looking at 0, which is 6 gigahertz, and then 1, which is 5 gigahertz. And if I were to look at 5 gigahertz, we'd see the same thing. We'd see all 3 station profiles in here. So, and summarized below here. So interesting that the probe, the iPhone didn't request the different station profiles, but the probe response did respond with all the station profiles. So I guess one way or another, it got the information it had requested. Okay, let's take a look at the authentication frames. So not a whole lot to see here as before. We do see that it is, for the authentication, it is showing that it supports multi-link setup, even though everything is basically shut off here. But it is showing its MAC address for the transmitter, which is the iPhone. So it's multi-link device MAC address, and then the response coming back from 6 gigahertz here with its MAC address. So as before, when we do the authentication, whatever band we're on is the band that the association is going to follow through on. Okay, if we jump into the association response here, there is a single packet that we captured for the response. And of course, it was on 6 gigahertz. And so for the multi-link, we do see, we've got the 6 gigahertz, of course, and we do see it responding with the station profiles for the other 2 bands. So that's great. So this is the first time we've seen a client do multi-link device setup across all 3 bands. So that's pretty cool. And lastly, let's take a look at the EAP packets, and we see a bunch of them here, which is already an indicator that it did enterprise. And if we take a look, it did. So we used EAP PEEP as the EAP method, and you know, we have all the back and forth for the EAP. And then lastly, here we have a success. So it definitely did a multi-link device setup across all 3 bands and authenticated over that, and is now capable of forwarding data. So now we could just hope for some updates in the future where the iPhone can enable spectrum puncturing, or maybe it's an AP thing where, you know, it's not puncturing out the channels, or at least shifting its traffic over to another link in time to congestion, which we saw it did not do. So that's a wrap for the iPhone. So look forward to the next video. We're going to go over the MediaTek 7927, I think it is. So look forward to that.